Welcome back. Today we're going to talk about global warming. A couple of questions to think about when we start today. Global warming, what is it? And what is your opinion about global warming and the human contribution of greenhouse gases to the atmosphere? Now, when I talk about this subject of global warming, I really need to always reiterate to students that there is no shortage of information out there, but you always need to be very critical of what you find. The first thing we want to look at is what the process of global warming is. As we look at this, we can say that the Earth's atmosphere and temperature is fairly constant, however, it fluctuates over time. What does that mean? Well, you can see in this graph here, we're looking at global temperatures, and this goes back 450,000 years ago. And when we talk about fluctuating over time, we're talking about this idea that the pattern goes down and up and down and up, and it fluctuates over time. What exactly is this graph showing you? Well, a couple of big things that you want to take away from this is that these points here, these low points on the graph, are when we would have an ice age in the past. So these are ice ages. And the other thing about this graph that I really look at are these points up here. Now, these are a bit concerning to somebody studying global warming because each of these peaks here indicates an extreme warming, but when these extreme warmings happen, we also often had mass extinctions. So if we have a mass extinction, that means we're going to have a loss of biodiversity. So I really want to point out that temperature fluctuations are common over time. We have a lot of data to show that these temperature fluctuations happen. However, the sway is between ice ages and oftentimes mass extinction events. So that's something to keep in mind as we go. Current global warming over the past 3 decades has been proven with scientific evidence, and so the debate about whether global warming is happening is no longer a debate. The debate is whether you think, or whether scientists think, if humans are really contributing to greenhouse gas emissions. So if we look specifically over the last 150 years, we can definitely see an increase in our emission, or in our global temperatures. So the overall pattern is that there is an increase of temperature. Now, how much of an increase? Well, it doesn't look like a lot. From back here in 1860 to closer to our present day in 2000, it was an increase in temperature of 1 degree Celsius. That doesn't sound like a lot, but in some cases it can be pretty significant. If you're talking about the accumulation of snow on a glacier, for example, 1 degree can have a pretty significant difference in terms of how well that glacier can accumulate and hold on to its snowpack. Our biggest concern is probably right here. This is the idea that in the last 30 years, roughly, we've had a pretty steady increase just in the last 30 years, and that's a steady increase above our kind of normal or average temperature. So there's definitely an increase going on there. Again, it's not a lot, but it is a warming trend, which is basically what we call global warming. So that leads us to this idea here. Are humans causing global warming? Well, if we do some real simple math, what we need to look at is the total of global warming, because we have things that are human caused, and we have emissions of CO2. And we're going to really focus on CO2 for today. Emissions of CO2 that are natural. So human versus natural. If we take the total of this, if we take this overall total, 439 plus 332 plus 29, we get an overall amount. Let's see here. We've got 11, 20, 6, 7, 8, 9, 10. We have an overall amount of CO2, and again, just basic units comparatively, of 800. If we take the human aspect of this, if we do 29 divided by 800, the human contribution to this is a mere 3.6%. So it's pretty safe to say that the amount of CO2 being emitted by humans is very small. However, even a very small amount can have a significant impact. So if we go down to the overall, we also have to consider what is reabsorbing this. So these are the emissions here. So we have our emissions from humans, we have our natural emissions, and we have oceanic emissions. Now we also have the fact that vegetation land, soils, crops, green plants, they can absorb lots of carbon, and the ocean can absorb lots of carbon. However, if we take a look at that overall total, this amount of emissions, this 3.6%, is going to cause an increase over time. And if we look at that overall increase in CO2, let's say if we look at the big picture, like 10,000 years, we can see that over 10,000 years, the levels of CO2 are relatively flat. So from about 500 years ago or so, even 200 years ago, our overall levels of CO2 are pretty close to this amount here. So we're pretty close to 275, and it only fluctuated up from about 265 at this level. So not a lot. And again, this is CO2 levels. This is in parts per million. So that means out of every 1 million molecules in the atmosphere, 275 of them were CO2. Now, if we look at the last 100 years, from approximately this point on the chart to this point on the chart, if we look at the last 100 years, we're going from 275, and our present day amount in 2010, roughly, or close to 2010, has gotten up to 390 parts per million of CO2. So again, that's parts per million, which doesn't seem like a lot. So this is where you really need to be critical and decide whether you think this is significant. This is a pretty obvious jump, and this exponential growth, or this huge jump of CO2, is a very steady increase. A lot of people know that this increase is due to things like industrial processes that humans are contributing to, and they're definitely contributing CO2 to the atmosphere. Is this the main cause of global warming? Well, that's for you to decide, to do more research and to figure out whether you think that's going to be an issue or not. Now, depending on how much warmer the Earth gets, there's going to be some changes, and that's inevitable. And these changes are, again, whether you think that humans will benefit from them or if they could be affected by them in a negative way. It could go both ways. For example, biome shift. If we take the continental or the lower 48 in the United States here, a lot of the farming goes on in this region in the United States. One example of global warming could be this idea of a biome shift, where the climate in this region is fairly constant. However, if global warming happens, the biome that happens here could shift this farming region north. So from a standpoint of a farmer, if your farm is located down here and you've always traditionally farmed in this place, you might all of a sudden find yourself in a less than ideal situation of farming. However, if you live up in this region here and the farming shifts up more into your region, you might find this a pretty beneficial thing, where you could never farm before, but you now have a new benefit to the land that you own. That's going to be very significant with a lot of things. If we talk about water cycle changes, like certain parts of the country could get drier, other parts of the country could get wetter or more moist. But some of the bigger concerns are definitely the fact that places like Florida down here, New Orleans, New York, these regions here are pretty susceptible to flooding and coastal inundation, where sea levels are going to rise. It's hard to say how much, and a lot of people will give you different ranges, But those regions near the coast, especially islands and other places like that, will definitely see the effects of a rising sea level due to a melting of polar ice caps. Anyway, like I said, this is a huge topic. This is kind of an overall summary of what the debate is, or what the argument is on both sides. I'm not trying to give much more than just some of the current looks at what's happening. It's for you to decide whether you think it's significant toward humans or not. Thanks for tuning in today. Keep on learning.